All right, moving into our 5-7, we have, we can state our goals in one sentence. It's to use congruent triangles to prove congruent parts. Use congruent triangles to prove congruent parts. It's kind of like setting up what our to-do list is for this whole section. Our to-do is going to be to try to prove two triangles are congruent using one of our congruence theorems, and then we can talk about the parts that aren't already marked congruent. Definition of congruent figures: figures that are the same size and shape. Same size, same shape. Corresponding parts that match up on congruent figures. We've said this different ways when we defined it. Match up on pairs of congruent figures. And then constructions we're not defining, but it's just when we use tools to create things, and we don't have to construct anything. Down in our notes section, I'm going to explain two things. Big idea that I call CPCFC. And then underneath that, we're going to come down and we're going to have a little, what is this section about? And a little to-do explanation. But what is this CPCFC idea? We're going to use this acronym throughout. And we're going to let the CPCS corresponding parts. So these two together, put the CP together, and that reads corresponding parts. Good, Faith. Now I'm going to put a word of, corresponding parts of. What do you guys think this next CF is? Congruent figures. Corresponding parts of congruent figures are congruent. Duh. If two figures are congruent, we probably only know that like three pairs of the parts are congruent, like especially on triangles. If we know that like two triangles are congruent, we've had to show 3 pairs of corresponding parts for some proof. This gives us permission to say that the rest of the parts of the triangles are congruent to each other. Corresponding parts of congruent figures are congruent. You're going to use that acronym throughout because I don't think you guys want to be writing that over and over and over again. So our job in this section is to use, we've got SAS, SSS, hypotenuse leg, HL, and then what did we put in there today? ASA and AAS to prove triangle congruence. So keep on keeping on with our proofs and whatnot, matching up sides and trying to prove triangle congruence. And once we've done that, we can then use this CPCFC idea to show all pairs of corresponding sides are congruent. Of corresponding parts, I should say. So one of these theorems leads us to say two triangles are the same, and then we can go pick up all the other sides of angles and pairs of sides and angles to identify as congruent corresponding parts.
But you said
once that is done, we can use the CPCFC, corresponding parts of congruent figures are congruent, to show that all parts are congruent. Now moving on from this side, we're gonna do some matching here. I think we can probably look at the first three and be cool with this. Grab your last sentence. I froze up in class. Now, when we go over to these proofs then, you guys, based on what I was just telling you, like it explains how to prove that the statement is true. So they just want us to get at this pair of sides is congruent. And as soon as I look at it, like UV and VX, you guys notice those two are not marked congruent. But they want us to try to prove that they are. So if we can match up and say that these two triangles are congruent, then we can come back and talk about those. And so then I've got to think about all this stuff in here that's given is based on markings. And so picking up my yellow colored pencil, I was doing pairs of angles before. So I got choices right now. I'm doing, do we have SSS? Do we have SAS? Do we have HL? Do we have, what else? ASA, or do we have angle, side? So there's our 5. Now, if we can match up to get to one of those, then in the end, we can say that those two sides that aren't marked are the same. So angle T and angle W. I got a given pair of angles. You guys cool with that? So I got some angles that are congruent. I turned that yellow. Then I'm looking at, I got a pair of corresponding sides that are congruent. This TV is marked the same as VW. And then what idea could I use, you guys, on angle V here? These guys, yeah, there we go. So since these two guys here are vertical angles, what congruence theorem then do we have? Angles with a side in between them. Take a look at it. Mine's in blue and yellow. Yellow to blue, side in between. Yellow to blue, side in between. You got it. So our color coding, I'm going to say this, ASA would prove congruence, proves congruence, congruence of the triangles. So by corresponding parts of congruent figures are congruent, that side UV has got to be the same as side XV. And then I'm going to just go back with my colors. I had a pair of angles in yellow. I had my side in red. And I had my other pair of angles in blue. So my color coding is given that. So I just color coded ASA. Mine's going yellow, red, blue. Start looking ahead at number 2. It's a right triangle. So I guess my question on 2 is going to be, can we go in and grab HL? Would HL work on 2? Could we prove HL on number 2? All right. Right angles. So I'm thinking HL on number 2 because of the right angles. So first thing I'm going to do is be like, all right, R and V and T. V and T here. And then I'm going to look, do I have hypotenuse leg? R to S is my hypotenuse. Beautiful. R to U is my hypotenuse. There's hypotenuse congruence. And then do we have leg congruence as well? I'm just picking up a green. Yeah, I got leg congruence. And then for this one, then, I just put my legs in green. I had my hypotenuse in red. HL proves congruence as these are right triangles. And let me guess, I didn't even look at what they wanted us to show. So it must be the other legs, huh? Yeah, TSVR. They just want us to talk about these two other legs then. Since we know the triangles are congruent, we go on and say then by corresponding parts of congruent figures are congruent idea that segment TS is congruent to segment VR. And then what do you guys think about number 3? What could we go for? Maybe SAS? We got 2 pairs of sides. Is the angle included? Let's go looking. LM, maybe SAS. I think we might have it. LM to LJ, pair of sides. It's given, it's marked for us. Pair of sides is marked. I got a pair of angles marked, J and M. I see what's coming. And then I got another pair of marks, JK, MN. And then the question is, what do they want us to prove? So if that's SAS, what are they getting at here? They want angle JKL and angle, wait a minute, angle JKL congruent to angle MLN. Oh. This is a little bit of a problem. Check out what I'm doing here, you guys. This angle JKL is right here. JKL is right there. MLN is right here. Are those congruent? Because they don't, what? They don't correspond to each other. So even though these two triangles, see, I had to go back and check, what were they trying? They wanted us to show these were congruent. Even though these triangles are congruent by SAS, these parts don't correspond to each other. So even though the two triangles are congruent, the angles of interest don't correspond to each other. The angles of interest don't correspond to each other or sit in the same position. So actually that right there, I'm going to put an X through it because that's just a false statement. The other ones were true.